This is the real-time rows, and this is a hard question because they're not giving us very many clues. They want to know how many integers are in the solution set of 2x minus 6 absolute value is less than 3. So first we need to come up with the two different universes. So there's a universe where 2x minus 6 is positive. In that universe, the absolute value sign does nothing, right? So in that universe, we have 2x minus 6 is less than 3. Or you can solve this. So 2x is less than 9, which means x is less than 9 halves. 9 halves you might also write as, how does this 2 go into 9? 4.5 times. Right, I'm putting it in decimal because I want to keep track of how many integers are inside it. So 4 would be less than this, 5 would not be. All right, now let's handle the rest of that absolute value. So there's another universe where 2x minus 6 is negative. In that universe, what the absolute value sign will do is it will multiply the quantity inside of it by -1, essentially. This is a great technique for neutralizing absolute values. So this is like saying -1 times 2x minus 6 is less than 3. So this is -2x plus 6 is less than 3. We can solve this now. So this is -2x is, let's see, 3 minus 6 is -3. And let's divide by -2 on both sides. And so you'll get -3 over -2 is 1.5. But we need to flip the sign. And the reason why you flip the sign, anytime you multiply or divide by a negative number, as we did in this step to this step, on inequalities, you have to flip the sign. Just memorize that. So we're almost done, and there's a little bit more due diligence that we have to do, and I'm actually gonna recommend that you skip it, but I'm gonna show it to you anyway. So like, if here what we've got is x must be greater than 1.5, so let's go from 1.5, and x must be less than 4.5. So what's inside that range? Well, we've got 2 is in there, 3 is in there, and 4 is in there. So I'm gonna pick 3 and be done with it. Now, there's a tiny little bit of extra work that you should do if you want to be super positive here, which is what we've solved for is x is less than 4.5. We did that under the guise of 2x minus 6 being positive. So if 2x minus 6 is positive, what we're saying is that's only true when 2x minus 6 is greater than 0. So you actually need to solve this one also. This is only true when x is greater than 3. So what you can see is that this result, x is less than 4.5, as a definitive solution, right? So it looks like we're saying all values less than x of 4.5 work to solve this, but that's not true. It's all values less than 4.5 and greater than or equal to 3 are guaranteed to solve it. So that includes 4 and 3. Or what we pick up from that first statement. Only 4 and 3. On the second statement, so 2 might still be in the running, but we just have to check. So 2x minus 6 is negative, which means 2x minus 6 is less than 0. So 2x is less than 6, which means that x is less than 3. So we get these things when x is less than 3. So when is x greater than 1.5 but less than 3? It would be when x is 2. So you see how I double checked every number and they're all still included in the range? You have to do that. This is being a little anal. So again, I would not do that on the ACT. I would just pick the 3 when you had done this analysis and then be done with it. But if you want to be super, super safe, you got to put in the extra time to do this little extra check as well, which again, I actually don't personally do, but